I know it was. It was not even an invitation, it was a command. Alright, so we are solving so it's just solving trig equations day 3. Alright. We have sine of 2x equals 1/2. So what is different from this equation today versus the equations that we've had the past 2 days? Doesn't equal 0. I could make it equal 0 just by subtracting the 1/2 over, though. It's 2x. We haven't had any that had a number in front of x before. Okay? So what makes these problems a little bit more complicated is that the inside, the thing that you're taking sine of, that inside part is going to be a little bit different than it's been before. Okay? So still the first thing we need to do is take the sine inverse. So we're still looking at our unit circle and trying to figure out where on the unit circle we have a y coordinate of positive 1/2. So if we look at our unit circle, pi 6 and 5 pi 6. All right, so here's what I'm going to write. I'm going to say 2x equals pi over 6, 2x equals 5 pi over 6. All right? And since this is a sine equation, I'm going to write plus 2 pi k. Plus 2 pi k. All right? Now, we're not trying to solve for 2x, we're trying to solve for x. So what do I need to do? Divide by 2. Divide by 2. Take this whole thing and divide this whole thing by 2. Divide that by 2. Actually, hold on. I'm going to write the whole thing. Take this whole thing and divide it by 2. Take that and divide it by 2. So now I've got my x all alone. If I had pi over 6 and I divided it by 2, it becomes pi over 12. Pi over 12. Okay? Plus, if I have 2 pi k and I divide by 2, pi k. Okay? So what this is saying is that if you take your angle and you cut your angle in half like that, then now the answers are going to repeat every pi k instead of every 2 pi k. So the answers are repeating more often. It's basically saying instead of the period of my graph being 2 pi, the period of my graph is now 2 pi divided by 2, which is just pi. Does that make sense? So our answers repeat more often. Okay? So we have pi 12ths plus pi k. Over here we're going to have x equals 5 pi 6 divided by 2 is what? 5 pi 12ths plus pi k. Good. So if we were doing a problem where they said find every single possible solution, then you would say x equals pi 12ths plus pi k, and x equals 5 pi 12ths plus pi k. That's what you would say if they said find all solutions for me. Okay? If they said find all solutions from 0 to 2 pi, then you have to do some work. This is what your calculators are for today. So I'm going to get my calculator out. The first fraction, I'm going to go ahead and type this in as a fraction, 1/12. And I'm going to do that because I want my other answers to be fractions as well. Okay? So it says that 1/12 is the first answer and that the answers repeat for every 1 pi. So I'm going to take 1/12 and I'm going to add 1 to that. So 13/12. I'm going to go ahead and write both of those down. So pi 12ths, 13 pi 12ths. I'm going to add 1 again. That is 25/12. And 25 divided by 12 is bigger than 2. So this answer is bigger than 2 pi and is not on the interval. Does that make sense?
Yeah.
This answer is too big. It's not on the interval, so I'm done with that answer. Now I'm going to do 5/12, and I'm going to add 1 to that one because those answers repeated every 1 pi as well. So I have 17/12, so I'm going to write down both of those answers. 5 pi 12ths, 17 pi 12ths. I'm going to add 1 to that. That is 29 twelfths. 29 twelfths is bigger than 2, right? 24 twelfths would be 2. 29 is bigger than 2. That's outside the interval, so I do not write that one down. So normally, if we were solving a problem and we said sine x equals 1/2, we would only get 2 solutions. But when we said sine of 2x equals 1/2, we actually got 4 solutions. Does that make sense? Okay. So that's kind of the idea of how these work. We're going to keep going. We're going to do some more examples. All right. For the next example, we're going to do sine of 3x equals root 3 over 2. Sine of 3x equals root 3 over 2. Okay. So what should we do first? Okay, so sine inverse. And when I write sine inverse on my paper, what should I really be doing? I should really be picking up my unit circle, right? I'm looking at my unit circle. So I'm saying where on my unit circle do I have a y coordinate of root 3 over 2? Pi thirds and 2 pi thirds. Okay, so on my paper I'm going to write 3x equals pi thirds plus 2 pi k. 3x equals 2 pi thirds plus 2 pi k. Okay. And what should I do next? Divide by 3. Divide by 3. So I have x equals pi thirds divided by 3, pi ninths, plus, what's 2 pi divided by 3? Yeah, 2 pi thirds. 2 pi thirds k. And then over here we have x equals 2 pi ninths plus 2 pi thirds k. All right, so if they wanted to know all solutions, they wanted every single possible solution, then we would just say this. This is kind of like the easy answer for these types of problems. Okay. If they want to know the solutions from 0 to 2 pi, our job is a little bit more difficult. This is where we got to get out our calculator and get the specific answers. Okay, so our first answer is pi ninths. So on my calculator, I'm going to type in 1/9. And I'm going to add to the 1/9 2 thirds, because the answers are going to repeat every 2 thirds of a circle. So I'm going to say, you can see it, 1/9 plus 2 thirds. 7/9, okay? And then I'll do plus another 2 thirds. Okay, plus 2 thirds. Okay, so we have 7/9, we have 13/9. Okay, we'll add 2 thirds again. We have 19/9. 18 divided by 9 would be 2. And so 19/9 is too big to be in our interval. So we're done. Okay? Then I have to look at the other solution, and I have to start there. So 2 pi ninths, and I'm going to add 2 thirds. So I have 8/9. and then I'm going to add 2/3 again, and I get 14/9, and then I'm going to add 2/3 again, and this is 20/9, which is too big, it's outside of our interval. So for a normal equation, we would have had 2 solutions on a unit circle. When you see 3x there, you have 6 solutions on a unit circle. Okay? Yes?
So you always add whatever the coefficient in the pi is?
Yes.
Okay.
Mm-hmm. And that's kind of, so what we're doing is we're finding coterminal angles, just the period of our graph is smaller than normal. So to find a coterminal angle for this problem, you're going to add 2 pi-thirds instead of adding 2 pi. Mm-hmm. So your answers repeat less, or more often, I guess. Okay. All right, how are your brains feeling about that? Are they confused? Are they making sense of it? It's a little bit iffy. Okay, next we're going to do cos of 5x. When you see that, how many answers are you predicting? 10 answers. Whoa. But I'm going to make this an equal -1 because I'm not as evil as you think I might be. I'm positive. Okay, so when it said 2x, we had 4 answers. When it said 3x, we had 6 answers. We are predicting right now that we are going to have 10 answers. That's our prediction. Okay, what do I do first? Cos inverse. And when I do cos inverse, what should I pick up? My unit circle. So I'm looking on my unit circle to see where I have an x coordinate of -1. Pi. Anywhere else?
No.
No. So are we actually going to have 10 answers?
No.
No, we're not. So 5x equals pi plus 2 pi k. So this problem is not going to have as many answers as we expected because -1 only happens on the unit circle as an x coordinate 1 time. It doesn't happen twice. Does that make sense? So if I had said this equation equaled square root of 2/2, then we would have had 10 answers. But since this is what they call a quadrantal angle, it's an angle that's on the quadrant line, we ended up only having, we're going to have 5 answers, okay? So watch for that. Don't predict, oh, it says 5, therefore we're going to have 10. You have to watch out for it. Sometimes it means we have 10, sometimes it just means we have 5 answers, okay? All right, so we have 5x equals pi plus 2 pi k, and then what should I do to get x alone? Divide by 5. So x equals pi fifths plus 2 pi fifths k. Okay. So if we wanted to write all the possible answers we could have, we would say x equals pi fifths plus 2 pi fifths k. That represents every single answer we could possibly get. If I only want the answers between 0 and 2 pi, how do I start my answers?
You do 1/5 plus 2/5?
Mm-hmm. So pi fifths, we actually don't need a calculator for this because it's fifths and we're adding fifths, right? So 1/5 plus 2/5 gives you 3/5. 3/5 plus 2/5 gives you 5/5, which is 1. So that's just pi. 5/5 plus 2/5, 7/5. 7/5 plus 2/5, 9/5. 9/5 plus 2/5 is 11/5, which is too big. So we're done. And we got 5 answers. All right. Brain's feeling okay?
Yeah.
Okay. We're going to try a tangent one next, just to see how we can handle that. What number should I put in front of that?
1, 3.
3. Okay.
0.
Okay, tan of 3x equals -1. Well, think about it. So, is this a quadrantal angle? It's not. It's not because it's tangent. So we're looking for a y divided by x that simplifies to be 1. We're not actually looking for a -1. Okay? All right, so first thing I need to do is take the tan inverse, right? And so I've got 3x equals, and I'm looking on my unit circle where I can see a y coordinate divided by an x coordinate that becomes -1. 3 pi fourths and 7 pi fourths. Now, what do we remember about all solutions for tangent? Yeah, do we have to use both of them? No, we can use one of them and put plus pi k. Okay? Do you guys want to use 3 pi fourths? Or do you want to use 7 pi fourths? 3 pi fourths. Okay, so I'm going to say 3x equals 3 pi fourths plus pi k. And that's all I have to write for this one because this is a tangent equation. If you chose to write both of them and you did plus 2 pi k for both of them, you would get the exact same answer. Okay? So if you don't remember that tangent is the special one, that's fine. You can still handle the problem. All right, what do I do to get x alone? Divide by 3. Okay, so x equals 3 pi 12ths. What's 3 pi 12ths? Pi over 4. So if you can kind of picture it, this 3 on the top and this 3 canceled. Does that make sense? So you have 3 pi 12ths, which is really pi fourths, plus pi thirds k. All right. So if we are writing all possible answers, that was it. Okay. It just gets a little bit messier if we're doing from 0 to 2 pi. Okay, so on my calculator, I'm going to type 1/4 plus 1/3. Okay, I get 7/12, so I've got pi fourths. And I've got 7 pi 12ths. Okay, and then I'm going to add 1/3 again. All right, so we've got 11 pi 12ths. Now here's the nice thing is once you see it looking like this on your calculator, do you see how it says answer plus 1/3? It means it's taking the previous answer and adding 1/3 to it. If you press enter again, it's going to do the same thing for you again. What? Yeah, you don't even have to type it. So 5 pi fourths is the next one. And then I press enter again, and I get 19 pi 12ths. And then I press enter again, and I'll get the last one. Yeah, that's kind of nice, huh?
Wait, how did you do that again?
I just pressed enter. It only works if it says answer plus, because then it's pulling your previous answer and adding 1/3 to it. So 19 pi 12ths and then 23 pi 12ths. And 23 pi 12ths is going to be my last one because if I do enter again, 9 divided by 4 is bigger than 2. 8 divided by 4 would have been 2. 9 divided by 4 is 2. Okay. All right. How are we feeling? We're pretty good? Okay. I'm going to add one more thing to it that's going to make it a little bit trickier. Okay?
Wait, don't move it yet. I haven't even gotten.
Okay, do you guys want to do sine, cosine, or tangent? Tangent.
Sine.
We already said tangent. What number should we put in front of x? 2. Do we want to do a plus or a minus? Minus. And then give me a radian measurement.
Wait.
Pi over 4, thank you. 6. All right, equals, what is something that tangent could equal on the unit circle?
-1.
Okay. Yeah, let's do positive one since we just did negative one. Sorry. Leah, you've been rejected. Okay. So, what do I do first?
Tan inverse.
I do tan inverse. And that really means I'm looking at my unit circle for where a y coordinate divided by an x coordinate equals exactly 1. Where's that at?
5 pi over 4.
Okay. And so for tangent, we've got two options. We can use one of them or both of them. It's up to you guys. Do you guys want to use the pi fourths or the 5 pi fourths or both?
Pi fourths.
Just pi fourths. Okay. So I'm going to say 2x minus pi fourths equals pi fourths plus pi k. So what I did is I said the stuff inside the parentheses, right? I took away the tan, so I have the stuff in the parentheses left over. So I said that stuff in the parentheses left over equals, and then tan inverse of 1 was pi fourths plus pi k. You see what I did there? So I said these two canceled. I took this and I copied it down here. And then I said tan inverse of 1 is just pi fourths. And I put the plus pi k, because that's how often it repeats. Okay. Yeah. It's because it's a tangent graph, and the tangent graphs, the answers repeat every half circle, and so you don't have to do a full circle. You can just use one equation and say they repeat every half circle and then do 1 instead of 2. All right, at this point, if I'm trying to get the x alone, what is the first thing I should move away from x? It's going to have to be the pi fourths, because you have to add or subtract things over before you multiply and divide things over, okay? So if I say plus pi fourths, is the pi fourths like terms with something that looks like this, or is it like terms with something that has a variable k on it? This is a plain pi fourths. Does it go with a plain number, or does it go with a number that has a variable? It goes with a plain number. So I'm going to say plus pi fourths. So it's 2 pi fourths, which is pi halves. We have 1 pi fourth added to another pi fourth. So 2 pi fourths gives me pi halves. So we had a slightly more difficult step to get started with, but now this is just like the other problems we did. Okay, so what do I do next? Divide by 2. X equals pi fourths plus pi halves. Okay, so this is our all solutions answer. If we want to find our 0 to 2 pi solutions, I start off with the 1/4 on my calculator. And I add 1/2. And so I've got pi fourths and then 3 pi fourths. And then I'm going to add 1/2 again. Five pi fourths. And now that my calculator says answer plus pi, now that it says answer plus 1/2, now I can just press enter to get the rest of them. So I've got 7 pi fourths, and then 9 pi fourths is too big. So we had a 2x, and we got 4 answers. Okay. Shall we do another one that looks like that? The only reason you would say no is because that was easy and totally made sense. Okay, let's do one more. Okay. Do you want to do sine or cosine? Cos. Okay, what number should we put in front of x?
3.
Plus or minus?
Minus.
Let's do, we did minus last time. Let's do plus this time. Okay. I'm going to say plus, I'm going to say 3 pi fifths. We're going to make it something weird. Well, that's not very weird. We're just going to do that. Okay. Equals negative root 3 over 2. Okay. So what do I do first? Cos inverse. Okay. So I'm looking at the unit circle. I see 5 pi over 6 and 7 pi over 6. So since this is a cos problem, we have to do 2. Okay? 5 pi over 6 and 7 pi over 6. So I'm going to take this part because this is what was left over once we got rid of the cos. I say 3x plus 3 pi fifths equals 5 pi 6 plus 2 pi k. And then I do the same thing for the second option. 3x plus 3 pi fifths equals 7 pi 6 plus 2 pi k. So since it's a cos problem, I have to do both options. I can't just do one. Okay. So I am trying to get the x alone. I have to subtract first. I can't divide first step. So I'm going to subtract 3 pi fifths. And when I subtract it, I can't subtract it from the one that has a k because they're not like terms. So I'm going to subtract it from this one, minus 3 pi fifths. So minus 3 pi fifths, minus 3 pi fifths. Okay, so 5, 6, minus 3 pi fifths. Okay, so 7 thirtieths. That's interesting. Did everyone get 7 pi 30ths? Yeah. Okay. So we don't have to be intimidated by that because our calculator is going to do all the fractions for us. So we're going to be fine. 7 30ths is weird, but we're going to be fine. All right, and then we also have to do 7 6 minus 3 fifths. And 17 30ths. So that's fun. Okay. And what do we do next? Divide by 3. Okay. So x equals 7 pi over 90. Yeah, 7 pi over 90. Ooh, that looks bad. Plus 2 pi thirds k. Okay. X equals 17 pi over 90 plus 2 pi thirds k. All right, so that is our all solutions answer. Now to get our specific solutions, how many are we expecting to have?
6.
We're going to expect 6. 3 from the first one, 3 from the second one. Okay, so I'm going to say 7 90ths plus 2 thirds. So I got 67 90ths and 127 90ths. So I'm going to keep my first answer, the 7 90ths. And then I had 67 90ths. And then I had 127 90ths. Okay. And if I do it one more time, I get 187 90ths, which is too big because 180 over 90 is 2. That's too many. Okay? So next, I'm going to go ahead and do 17 90ths. plus 2/3. So 77/90ths. And I get 137/90ths. And then if I do it again, I'd get 197/90ths, which is too big. So did we get all of our answers?
Yeah.
Okay. Make sure you put pi on all of them. That would be a common mistake a student would make, is forgetting to put the pi. Okay, where are your brains at? We can handle it, okay? All right. So when is the situation where we might get less answers than we expect? So the all solution answer is going to be less with a tangent because we're going to have one equation instead of two. Where's another situation where we could have less answers than we expected? Yeah, when it's on the y or x-axis. And that's specific. That's not with the zeros. Are you listening? That's not with the zeros, because 0 shows up as an x-coordinate twice. And 0 shows up as a y-coordinate twice. So it's specifically if you have a sine equation or a cosine equation equaling 1 or -1. If you have a sine or a cosine equation equaling 1 or -1, you're going to have less answers than you expect. Does that make sense? Okay.